Explain like I'm 5. Why force calculated by acceleration rather than speed? The famous kilogram times ms squared. I had a hard time to understand what can s squared can be, but eventually I came to conclusion of accepting as a concept instead of something to think spatially. To keep it super simple, a force is a push or a pull that makes something change speed. If it's not changing speed or velocity, if it's not accelerating, then a force isn't being applied. Maybe an intuitive way to think about it. Imagine you push a block across some frictionless surface. It would take some force to get it up to 5 miles per hour. But once it's at 5 miles per hour, it doesn't take any additional force to keep it moving at that speed. You could stop pushing, it would just keep going. Because a bunch of words have very specific meanings in physics. Velocity, mass, momentum. Acceleration, mass, force. Force, distance, work. Work, time, power. And so on. How you get acceleration is a change in velocity. So, you are moving at 4 meters s. Acceleration is a change in velocity over time. Since velocity is ms and acceleration is a change in velocity over time, that would be mss, i.e. ms2. Newton's first law states that an object in motion will tend to remain in motion at a constant speed in a straight line, unless acted on by a constant force. You don't need force to keep something moving if an object isn't changing the way it moves. It cannot impart a force on anything. Only when an object's motion changes, in other words, when it accelerates in some direction, does it become possible to impart a force on things. That's why acceleration is used to calculate force. Acceleration is when force happens. So think of Newton's law that an object in motion stays in motion. If you have an object A moving at 10 km per hour and you have something behind it, object B, at 10 km per hour, there is no force applied to object A. If the object B moving towards object A is moving at 20 km per hour and impacts it, then the force applied by object B to object A accelerates the object A by a corresponding amount. Think of force like a push or pull. Something that is moving at a constant speed with no friction has no force on it. When you want it to go faster, slower, you apply force and its speed slows down. The rate something speeds slows is acceleration. So force is related to acceleration, not speed. Because applying force doesn't produce speed. It produces a change. If I apply force to the ball in my right hand, I change its speed and direction from essentially zero relative to me to however many featuring s in the direction dictated by the force I applied. The amount of force required depends on the amount of change in velocity. Acceleration is measured in ms squared because speed is in ms, distance over time. Acceleration is the change in speed. The time element is present twice. Ergo seconds squared. 9.8 meters s squared means that in free fall, your speed increases by 9.8 meters s every second. So in order for something to be accelerating, it needs to have additional energy. Therefore, an object that is maintaining 20 miles per hour does not have the same energy as one that is at 20 miles per hour, but gaining speed. The amount of energy involved is integral to the amount of force involved. So any way this can change has to be accounted for in the formula. The equation describes the net force required to produce an acceleration in a body of mass m. Thus, if a body experiences zero net force, it has zero acceleration. This is not to say body undergoing zero acceleration has zero force acting on it. For example, a rocket going vertical has the force of gravity acting on it and the force from the rocket. If the upward force from the rocket perfectly balanced the force of gravity, the rocket would have zero net force acting on it and would not accelerate. So now after all this answers, I wished if I asked to explain like I'm 5 what a square or cube unit actually means in reality. This is not supposed to be about motion, but that things seems kinda imaginary. Or maybe I got the answer but trying so hard to understand. You have a mass of 1 kilogram. The mass is sitting on an air bearing or other surface with negligible friction. You apply a force F of exactly 1 Newton to the 1 kilogram mass and you push for exactly 1 second. After that second, the mass is traveling at velocity exactly 1 meter per second. 1 1 kilogram ms squared. F mar. AVT. VST. Therefore, ASTT or ST2. It describes how much velocity changes in time. So FMST2. That's what kgms2 means. 1 Newton. The unit of force is the amount of force needed to accelerate an object weighing 1 kilogram by 1 meter s2 in a vacuum, or, to generalize, the amount of net force needed to do that. 1 kilogram 1 meter s2. The initial velocity is irrelevant, as Newton's first law explains. Think about driving a car. You feel the lurch when you speed up. But if you are going the same speed like on a highway, you don't feel anything because your accel is 0. Imagine you're in empty space traveling at some velocity. There is no force acting upon you, so you just keep going along at the same velocity, v. Now, let's say you want to stop. You need to change your velocity to 0. To do this you need to decelerate. And to do that requires a force acting upon your mass. You can measure your velocity once per second to see how much it's changing and estimate how long it'll take to stop. So that's dvs, or in units mss or ms2. A square second might seem strange, but it's shorthand for MSS. Meters per second squared isn't that scary. Imagine you start driving a car. First second you're doing 0 kilometers per hour. Second you're doing 10 kilometers per hour. Third second 20 kilometers per hour. And so on. Every second you're increasing your speed by 10 kilometers per hour. Or in other words, your acceleration is 10 kilometers per hour s, or 10 kilometers hour second. This is how you can think of acceleration distance per time squared. FdP dt dmv dt mdv dt mar. If m is constant, force makes the velocity start to change with time. In 2 or 3 dimensions, the force might not change the speed, but only the direction of the velocity. In a vacuum, if an object is already moving at a specific speed, no energy is required to continue move it at that speed. Force is only required to change that speed. A large force applied to an object with mass will speed it up from rest quickly. A small force will speed it up slowly. If all we know is the object's speed and not how much time it took to get to that speed, we have no idea how strong a force was applied to it. A baseball in space, moving 100 miles per hour, will keep going at that speed forever. No forces are involved. If something happens to it, like it hits the moon, then forces are involved.